together. In a polynomial, what kind of exponents do we see? Whole number exponents. That means your exponents can never be a negative or a fraction or a decimal, any of those types of things. How do you identify the degree? Highest power, if the terms are added and subtracted together. Okay, so if I look at this first one, is that one a polynomial?
No.
Why? Your exponent isn't a whole number, it's a fraction. B, would this one be a polynomial? Yes. If you multiply it all out, we don't have any negative or fraction exponents, so that's okay. I did ask, if it is, tell me the degree. So if I multiply this out, what would be my highest power of x? So right, we have 2 right here, 1 here, and 1 here. So if you multiply it out, you would get 4. I also asked for you to give me the end behavior. Remember, if it's an even, it looks like a parabola. Both ends point the same direction. But I put a negative 3 in front of it, so it would be... Okay, you guys take a second and do the next 2 on your own. C. Is that a polynomial? Yes. Degree, careful, it's not just the first term. What would be my degree? Okay, so how come on B we added all these exponents together, and on C I just take the biggest? What's the difference? Right. On B we had the parentheses. All these things were multiplied together. Your degree is the highest power when everything is multiplied out. So if it's in factored form, you have to put them together. If it's already multiplied out, you just pick your highest. So this one is yes. Degree is 5. Okay, in behavior, I saw some issues with that. Remember, if it's an even, it looks like a parabola. If it's odd, it looks like a chair. This has a negative 2 in front of it, so what does that do to our chair? It's going to flip it, so now it's up, down. Okay, in behavior is a question that you should never miss, even if you've forgotten the rules. Why? You can graph it. So if you struggle with those rules, take a second and graph it and double check yourself. Make sure you've got it correct. Okay, D. This one's a polynomial. Since it's in factored form, we have to think about if we multiplied it out. So we would have 2, 3, and 4 more, so we have a degree of 7. It's a positive coefficient, so our in behavior would be down, up. Any questions there? Okay. Number 2. The minimum possible degree. What do we look at to answer that question? There are 3 turning points, so my degree has to be at least 4. The degree is 1 more than your turning points. If you can't remember that, you could always think about if I drew an imaginary axis in here, the most places it could hit 4 places, so it has to be at least degree 4. Domain. Okay, think about left to right. This end keeps going to the left forever. That one goes to the right forever. So we hit all of them, negative infinity to positive infinity. The range, bottom to the top. So this is going down forever, so we're hitting all the negatives. We stop here at our highest point, which is b. So our range is negative infinity to the y value of that point, which is b. Because you do hit that point, it gets a bracket. Okay, I want you guys to look at C and D. See if you can answer those two questions on your own. So tell me the difference between the local and the absolute.
Local isn't really the highest, it's just where there's a turning point.
Mm-hmm.
And extreme is like the actual very top and the actual very bottom.
Right. Local doesn't have to be the highest or lowest on the entire graph. Just higher or lower than the surrounding point. So it's like a turning point. So looking at this, my local max would be at A, B, and CD. It is okay if you just give the Y values. You could say B and D, that's fine as well. Local min, so lower than the surrounding points would be E. I can't really tell if that's an F or a T, but I would accept either one. Okay. D, absolute, means it's higher or lower than everything else on the graph. So what is the actual highest point we ever hit on this graph? AB. Absolute min, lower than everything else on this graph. Right, these ends keep going down, so there is no complete lowest point on here. Number 3, I want to write a polynomial. Okay, if negative 3 is a 0, what do you write as your factor? X plus 3. You always do x minus your 0, so it's the opposite sign. If the multiplicity is 4, what do we do with that? The multiplicity just tells you essentially the exponent. So my 0 is negative 3, the multiplicity is 4, so it's to the 4th power. Okay, then we have 1 with a multiplicity of 3. So if 1 is a 0, we write multiplicity of 3, so we put a good. Okay, currently this would be degree 7. I said it's degree 8. I also told you 0 is a 0. So what would I put? X minus 0, x plus 0, aren't those all the same thing? So you can put your x wherever. If you put it at the end, that's fine. A lot of times you'll see it at the beginning. It doesn't make a bit of difference, just as long as you have an x in there somewhere. So now we have degree 8. Okay. Number 4. I want to write the equation of the polynomial from this graph. Okay, so I see -2, we hit the x-axis. It's an x-intercept. That means it's a 0. So if -2 is a 0, what do we write? X plus 2. Okay, what do you notice? What happened at that 0? Bounces up, which means we need square. Okay, the next place we hit the x-axis is at 3. So we need. There's one other piece of information you can get from this graph. I hit my y-axis at 4. So that's like saying the point 0, 4 is on this graph. Do you remember when we found the coefficient out here? So there could be some number, let's call it A, out here. What we're going to do is plug in 0 for all of our x's and set this thing equal to 4. So we would have A, 0 plus 2 is 2 squared, 0 minus 3 is -3, equals our y value, which was 4. 2 squared is 4, times -3 is -12. Divide by -12, and A is -1/3. So my final polynomial is -1/3 x plus 2 squared x minus 3. I want you guys to take a few minutes and try the next couple questions on here. So try 5 and 6. If you want to talk with somebody else, you're welcome to do so. So we're dividing by x plus 4. I want the quotient. So what do you put in your box for the synthetic? -4. You always do the opposite. Okay, coefficients. This is where we had mistakes. You had a 1x to the 6th. There is no x to the 5th, so you need a 0. -16x to the 4th. No x cubed. 1x squared. There's no x to the 1st. And then the -16. So 1 comes down, we multiply and add. Walking around looks like you guys are really good with the synthetic. It's just you missed a 0 when you were setting it up. So I asked you several questions. What's the quotient? This is my remainder constant x, x squared, x cubed, x fourth, x to the 5th. So my quotient is what do you get when you divide this? So that would be my quotient. Is it a factor? Yes. What does it mean to be a factor? The remainder is 0. If all I cared about was whether or not it was a factor, if I didn't need the quotient, you could just plug a -4 into your polynomial to get your remainder out. Okay, number 6, a polynomial of degree 8. That means there has to be 8 zeros. I gave you some of them, and I asked for the remaining ones. Okay, so here are my zeros. If 3 multiplicity 2 is a 0, all that tells me is 3 works 2 times. That's 2 of my zeros. If 6i is a 0, what else is?
The conjugate.
The conjugate. So if 6i works, so does -6i. If -4 minus I works, so does -4 plus I. If 3 plus 5i works, so does 3 minus 5i. Remember, on the conjugate, you only change the sign on your I. So I said degree 8. We had 2, 3, 4, 5, 6, 7, 8. That's all 8 zeros. So that question, really all I wanted to is for you to recognize that if I give you an imaginary 0, its conjugate also works. This is really the starting point for what will be on your quiz tomorrow. So this was the first thing that we did in section 4.3. So everything from here on is fair game for your quiz. Any Any questions there? Alright, so in this section we started graphing. And I asked you a lot of questions. Some of them came from previous sections, like talking about degree and end behavior. That's not new. But putting it together on the graph. So if I look at this one, degree. Since it's in factored form, we have to add them together. We have 2 here, and 1 here. So the overall degree is 5. In behavior, of course, if you're in doubt, you can graph it. We know that if the degree is odd, it will look like a chair. There is a negative in front, so that would flip it, so it would be up, down. Okay, why don't you guys try to finish this question? Find the zeros, multiplicities if needed, tell me if it will go through or bounce at each of them, give the y-intercept, and then draw the graph from your information. Make sure you are plotting the information you find on your graph. Zeros and multiplicities. So to find your zeros, if it's in factored form, you just set each parenthesis equal to 0. So what makes x minus 1 0? 1. Because it was a squared, you need to put m2, multiplicity 2. Then we have a 3. It was also squared, so m2 and negative 4. Then I ask you if the graph goes through or bounces at each of those. When I'm asking that question, you are looking at these multiplicities. Even multiplicities mean the graph will bounce. Odd will go through. So we will bounce at both the 1 and the 3. Negative 4 just had a multiplicity of 1, so we'll go through at the negative 4. Y-intercept is where you cross the y-axis, so you plug in a 0 for your x's. So 0 minus 1 is negative 1 squared. 0 minus 3 is negative 3 squared. 0 plus 4 is 4. So 9, 36 times 1 is 36 times a negative gives me a negative 36. Then you have to plot all this on your graph. So I hit my x-axis at 1, 3, and negative 4. Y-axis at negative 36. I told you it was okay if you just put a mark, but make sure you label that. My end behavior was up, down. So my graph should start up here and end down here. You really don't need your calculator at all to graph this. We said we'd start up here. At negative 4, the graph goes through. Okay, have to hit your y-intercept, come back. At 1, the graph will. At 3, the graph will. And we said it would end going down, which it did. Now, is this graph perfect? No, absolutely not. It may come way down like this and then come back. You know, I don't know. The graphing calculator could give you more information there, but what I'm looking for on your graph, when I grade this, I'm checking that you have all of these intercepts at the correct spot. Those dots are the only place you can touch the x or y axis. Don't hit it anywhere else. Do you have the correct end behavior? Did you correctly bounce or go through at each? All right, number 8. So these questions on the Math Excel, I know you can kind of cheat a little bit because you can look at a graphing calculator. But on the quiz, I am going to ask you to list all the possible zeros. So you have to know how to do that. The maximum number of zeros is the same as what? The degree. When I say how many zeros can this have, I'm asking the degree, which is 3. So the maximum number of zeros is 3. My degree is 3. What would my end behavior be? Down, up. Okay, list all possible zeros. We did this on Thursday. We talked about the P's and the Q's. So the p-values come from where? The constant. And it's everything that goes into this negative 12 evenly. I told you every time, every number you put will have a plus and minus. So what can divide 12 evenly? 1 and 12, 2 and 6, 3 and 4. Okay, then you need Q. Where does Q come from? Leading coefficient, which was our 2. What's everything that goes into 2 evenly? Plus minus 1, plus and minus 2. So on the quiz, I expect you list your P's, you list your Q's, and then from that we make our list of possible zeros. These are the things that might work. Remember, to do that we do P divided by Q. So 1 over 1 is 1. 1 over 2 is 1/2. 12 over 1 is 12. 12 over 2 is 6. 2 over 1 is 2. 2 over 2 is 1. I already have that on my list, so I don't have to write it again. 6 over 1 is 6. I already have that. 6 over 2 is 3. 3 over 1 is 3. We've got that. 3 over 2. 4 over 1 is 4. And 4 over 2 is 2, which I already have. So I know that on the Math Excel you probably didn't do that in its entirety because you didn't have to type all those in most of the time. But I will break it down like this on the quiz, and you have to be able to make that list for me. Then, those are the ones that might work. How do we find out what does? Okay, the shortcut is to look at the graphing calculator and see which one is an x-intercept. We try to avoid the fractions if we can. So everybody graph it, find where it hits the x-axis for me. Let me know when you get one. Has anybody found one yet? -4. So if you're not sure, how will you know if it doesn't work? You're going to do your synthetic and you won't get a remainder of 0. We're going to do synthetic with the one that we think will work and our coefficients. So 2, 3, -23, and -12. Okay, 2 comes down. 2 times -4 is -8. 3 plus -8 is -5. -5 times 4 is 20. Add to -3. -3 times -4 is +12, and that adds to 0. So it did work. At this point, we have 2x squared minus 5x minus 3. We can factor that. How? Box method. What if at this point it came down to be like an x cubed or something that we couldn't do box method with? What do we do then? If it's a quadratic but it doesn't factor nicely, we can do quadratic formula. If it's like 4 or 5 terms still, then we can check for grouping. We can also, if that doesn't work, go back to our graph and find another 0 and do synthetic again. So we have a lot of options at this point. Okay, so these multiply to -6 and they need to add to -5. So that would be -6x and +1x. So factor, we can take out 2x and 1, x minus 3. Okay, I asked for the remaining, or to find all the zeros. So, we know -4 works, because we did synthetic with that. If you set 2x plus 1 equal to 0, we get -1/2. If I set x minus 3 equal to 0, we get 3. At the beginning, we said we could have 3 zeros, and I just got all 3. I didn't ask for it, but if I'd wanted the factored form, we have 2x plus 1, x minus 3. What else would you have to put with that? The x plus 4. If I said factored form, that's when you have the x's. Okay, through or bounce. All of these have a multiplicity of 1, so the graph will go through. Y-intercept, if I plug in a 0 for all of my x's at the beginning, we get 0 plus 0 minus 12. So y-intercept -12. Now let's graph it. So our in behavior, we said it should start low and end high. We hit the x-axis at our zeros, -4, -1/2, 3. Y-axis at -12. Those are the only places you can touch. So we'll start down here. We go through all of the zeros. Gotta come down and hit our y-intercept. Come back and hit the next 0 and go through. It should look like this. How can you double check yourself? You can look at your graph on your calculator if you need to double check something. Okay, so those are probably the longest problems. They involve a little bit of everything. Any questions there? Take a second, look at the last one and see how far you can get with it. We've got about 8 minutes, so I'll give you a couple minutes to try it on your own before we talk about it. Synthetic. I've got a couple people that just really hate doing synthetic with the eyes, and so I've noticed that even if I give them an imaginary 0, they tend to make their p's and q's and possible zeros, and you could do that. It will work. You'll find a real 0 and then get down to a quadratic and you can solve with the quadratic formula or something. So that certainly does work. Shortest way is probably if I gave you the 3i, we can just jump right in with that. So coefficients. Three comes down. 3 times 3i is 9i. These are not like terms, so you can't add them together. Now you need to do 3i times -1 plus 9i. So 3i times -1 is -3i. 3i times 9i is 27i squared, which is, so we get -3i minus 27. When you add, the 27's cancel and we have -3i. So 3i times -3i is -9i squared, which is 9. Add, and that gives me a 0. So it turned out okay, but I still have i's here. What can we do? Do it again with -3i. So when you do that, you ignore the 0 and you just bring down the rest of it. So 3 comes down. 3 times -3i is -9i. Add and gives you -1. Negative 1 times negative 3i is positive 3i. Adds and gives me 0. So there's my remainder, my constant, and x. So this is 3x minus 1. I asked you for the remaining zeros. So I already told you 3i worked. You're telling me the other things that worked. So we also had negative 3i. And then if you set 3x minus 1 equal to 0, 1/3. It was a degree 3. We should have a total of 3 zeros. I gave you the first one. You had 2 left to find. This time I also said, and write the factored form. So, since 3i was a 0, you would have x minus 3i. For the negative 3i, you would have x plus 3i, and then we had the 3x minus 1. Alright. What questions do you guys have? Okay, so questions 6 through 9, that's what your quiz will be over tomorrow. So I would definitely look back over those before tomorrow if you were struggling on anything today. The Math Excel is still open. Finish that up if you have not. Come in during advisory if you have questions. And then after the quiz tomorrow, you will get your study guide. Can we clean the desk?